Hello, my name is Antonia, and with my classmates Ana Sofia, Gabriela, and Hugo, we made this project, Predicting Gender-Based Violence in Mexico, a machine learning approach. Gender-based violence is a huge issue across the whole world. The World Health Organization estimates that about 30% of all women have been subjected to intimate partner violence, non-partner sexual violence, or both at least once in their life. In Mexico, the National Institute of Statistics reports that 60% of women older than 15 have suffered some sort of physical or sexual violence, making the problem even bigger. One of the main issues with gender-based violence is that there is a lot of underreporting. This happens for several reasons. Fear, because many times victims continue to see their victimizers regularly. Many times they live with them. Also, sometimes they don't trust the judicial system will help them and leave them in an even worse position with the victimizers. So it is very hard to identify who is being a victim of gender-based violence. The development of a quality survey requires high-level training, very strict interview protocols, and large monetary investment, because you need to have people that are very well trained to tackle the issue. That is why our goal is to produce a short set of variables that can be easily asked via questionnaire or survey that will help identify the victims of gender-based violence. Using our machine learning models, we hope to reduce the amount of variables needed to predict. Our data source is a survey called the National Survey about the Dynamic of Relations in the Household. We used the one in the year 2016. This is a survey that is done every 5 years by the government of Mexico, in particular the National Institute of Statistics and Geography. In the year 2016, there were 142,000 households approximately surveyed. From this household, the interviewer take the women over 15 years old and ask them particular questions. So we have socio-demographic characteristics about the households, and also perceptions of gender roles, economic independence, and support system for the women of the household at the individual level. The survey structure comes with a general questionnaire where come most of the socio-demographic and also house characteristics, how many families live in the house, economic characteristics. And also we took the general survey to aggregate other characteristics, like how many men live in the household, how many women live in the household, how many women have finished high school in the household, among others. And there are 3 other questionnaires that are directed to the women. This can be married or united women, separated or divorced women, and single women. We took our sample consists of only women that responded to questionnaire A, married or united women.
Okay, I'm going to talk about the descriptive statistics of this exercise. As Antonia was mentioning, in Mexico in 2016, 66% of women reported episodes of gender-based violence, and 34% mentioned that they have suffered from physical violence. In this map, we can see the geographic distribution of the target variable of interest in this exercise, which is the percentage of women with a partner that has suffered from any kind of violence. As we can see, the prevalence rates oscillate between 30 and 50%, and the highest prevalence rates are located in the center of Mexico. Here we can see the number of violent episodes, excluding zero, because zero was the most repeated value, and including that value in the graph didn't allow good observation of the episodes. So we can see here like the probability and the number of episodes. So there's a very low probability of episodes being more than 5. So which machine learning, so for developing our machine learning models, we first pre-process the data. So for missing value imputation, we imputed median values to numeric variables, and we imputed the mode for categorical variables. We also did an expansion of categorical variables, like one-hot encoding, to have only 1 and 0s in each of our columns, and we did correlation and polynomials. And finally, we removed highly correlated and constant values. Finally, the models that we use are logistic regression, ElasticNet. Well, first, since we had a classification problem to classify which woman is suffering or not from domestic violence, first we use a logistic regression ElasticNet as a simple and like a first approach. And then we jump to nonlinear models, which are tree, random forest, PCA, and clustering. And for all of these, we use tenfold cross-validation. PCI and clustering is not shown in the presentation because we didn't obtain good results since all of our data points are very similar. And well, we use PCA to reduce the dimensionality of our data.
So in order to choose from these three models, we use very standard scoring metrics that are commonly used for classification problems. So for instance, we could see that in the table you have in front of you, we have recall, precision, and accuracy. In this particular case, I mean, we all know the formula for recall and precision, for instance, but they have like a very intuitive interpretation. So for instance, precision is the share of women classified as victims who are actually victims. So this metric would be maximized if we classify 10 women as victims and they are actually victims. And then we have recall, which is basically the share of all women who were correctly classified as victims. So among all the true positives, how many of those we were actually able to reach. So, well, you know, after a bunch of discussions, we ended up deciding that it's a lot better to actually maximize recall. And the reason behind this is because we want to avoid leaving any type of women behind. And we believe that recall is actually the correct metric to actually keep that in mind. And well, these are the average scores for our three models. But if we go to the next slide, I think we are going to have a more intuitive look at what's going on. So basically, this is the precision recall curves, which basically maps every single recall score compared with its precision. And again, in this case, what we're looking at is at our three different models and how they perform. In this case, we would like our model to be as high in the curve as possible. And as we can see in this case, it seems like logistic regression is doing a better job than random forest and decision tree. Well, the random forest is actually pretty close to the logistic regression, and it doesn't seem like there's a contest for the decision tree. And finally, if we go to the next slide, again, what we're trying to do is we're trying to compare so in terms of feature importance, we ended up looking at what are the features that are more likely to predict gender-based violence. And we were a bit surprised that, for instance, the one that was more commonly found to be an important feature, which is the first one in the graph, text to family about her problems. It's a question that asks women, who do you talk to when you have any type of problem? Right? And in this case, the answer was they talk to their family. And it seems to be very predictive of what's going on. Also, we were very surprised that we did not find any type of social demographic characteristics that were very predictive. And we were also surprised that these questions that we found are consistent across models. So if we compare this graph with the one from the decision tree and with the one with the random forest, you will find that the questions overlap a lot. So it does seem like the same type of questions are the ones doing the most of the job in terms of predicting the outcome that we're trying to predict.
The next figure shows the distribution of prevalence of violence based in the model's testing set. And we can see that, in fact, the box plots overlap a lot. Even the medians are very close. Therefore, the models are not doing a good job at giving high probabilities to those that have suffered violence and low to those that have not. So this paper represents an initial step towards using machine learning methodology to predict gender-based violence in Mexico. And the purpose of this exercise was to offer non-profits and government agencies a target point to design screening tests to detect violence. And in this sense, even though that the metric scores of all of our models were not high, we do get similar features when getting the feature importance of each of our models. So we have some caveats and limitations. First of all is the lack of reporting. As we mentioned above, it's hard to identify victims because there's a lack of report. And also, it's important to say that, sorry, it's important to say that there's this is not a causal relationship between the subset of questions we use and the victims. It's only we only aim to get a subset of questions to be used on screening. Also, this is a very delicate issue that affects women's life in a very intimate way. The use of this tool must be done with extreme caution, and the human subjects need to be informed and to show consent. And furthermore, we must also protect the privacy of the information they provide and of the possible treatment that they might receive due to these responses. Thank you.